which is speed of light, first principle, minimal slot durations, versus the pragmatic incrementalist approach of just picking the low-hanging fruit and not necessarily aiming for the optimal stuff. So we're going to get Barnabé kicking things off with rainbow staking. Thank you.
Okay, yeah, so I'll talk a bit about rainbow staking, this, let's say, framework that I wrote about last year in a post that was trying to make sense of many different ideas that had been published before that by Vitalik, Dankrad, Justin as well. Yeah, I'm Barnabé from the protocol architecture team. I'm happy to be here. So I would say leading question that's kind of hiding behind all of this is, what will staking look like in 5 years? So there are many layers to staking. There's the consensus mechanism, there's the leader selection with all the validators, there's the economics of it, and the staking experience that we have today could be very different, let's say 5 years from now. So today we have this single entry point. You have to stake 32 ETH. That signs you up to become a network operator, a validator. And basically you are tasked with doing pretty much everything that we can think of that should fit on a machine that works for us. In the future, we think it makes sense to possibly unbundle the services that validators are doing even further. And that's what underpins the idea of rainbow staking. So having much more diversity and many differentiated services done by different service providers. So this is a quick map of stuff that is done today by the machines, censorship resistance by making blocks, FFG, finality gadget, function as RPCs, LMD Ghost for the available chain, syncing the node and the sync committee, proposing blocks and being the builders, sometimes if you don't outsource it. But one of the things that is, let's say, at the core of the staking experience for you as a validator is that your stake, this 32 ETH that you put in deposit, is fully slashable. And this is what we say provides us with this feature that we hope is useful to people who consume Ethereum, which is this economic security. There was a lot of debate, or there's always a lot of debate on what economic security means, so I want to go a bit into this because I think it's also important to understand why unbundling makes sense. So economic security is really the ability for the network to say X if will be lost if Y happens for some amount X and for some outcome Y. So for instance, if we ever had a safety fault of a finality gadget, FFG, we should be able to say, or we will be able to say, at least a third of the ETH that is currently staked needs to be slashed. And so we can basically evaluate the total loss of economic value to the network. Another part of a staking experience is the pressure to delegate. And I think we've seen now that delegation is almost inevitable in proof of stake. That's just a natural consequence of the phenomenon of separation of capital and labor. And in fact, unlike proof of work, where you had to, the capital is machines that are doing this hashing, in proof of stake, the capital is ETH, so it's much more liquid, which means it's also much easier to delegate. And when you have a smart contract platform that underpins the network, it's even easier because now you have all this infrastructure to do all these programmatic maneuvers that allow people to pool, to delegate, and to have pretty sophisticated payout systems. And so one thing that's also to note is that the capital, let's say for me as an ETH holder or for people who are looking for ways to allocate their ETH, is that they're always seeking yield. That's usually what capital does. And so they tend to go towards delegating where the capital has the highest efficiency, and so where the operators are the most capital efficient. When we put these two things together, like the economic security and the delegation, the story gets a bit unclear. And in particular, the act of delegating muddies a little bit this story of economic security. Like we say, X ETH will be lost if Y happens, but we don't really say whose ETH it is that gets lost. Like, is it directly the ETH of people who attacked, like when I give my ETH to Lido, for instance, to delegate, and they are part of the validators that are slashed? Is it me who attacked the network? Is it Lido as a protocol? Is it one operator of Lido? It's not always very clear. So the delegate could be at fault and lose the stake of their principal, so the person who stakes with them. And we have this principal agent problem that means essentially that, yeah, we can have a faulty agent that can be much cheaper to corrupt than the amount X that is lost and still get a network fault. It doesn't mean that economic security is a meme, like there's a lot of positive things from having this constraint of X if being lost, but it just does not also mean that X is the cost of attack to the network. And so why do we still have this idea of economic security, or why I think we have it? It's because we want to impose a certain amount of discipline on the network. Like, we want the principals, so the people who provide the capital, to choose their agents carefully, like to choose the operators that they delegate to in a way that, yeah, they're conscious of the risks that the network carries, and they also ask their agents to essentially level up, like to be as credible as possible, to provide guarantees that the agents are just not going to get trivially compromised or participate in attacks. And so, for instance, what we're seeing now is innovation with the dual governance of Lido, distributed validator networks, and many other systems that allow us to be more confident that the agents are not going to be compromised. Another positive effect is having this possibly very bad outcome, and the commitment that we will go through with it because it's programmatic, means that we really have an incentive to make client diversity work. And that prevents against what I would call oopsie slashing, where we have a consensus bug in a majority client and we finalize like something bad, and then a lot of stake could be lost. So having economic security is, I believe, good, but it does impose like a lot of constraints and pressures on the network. In particular, for home operators, it makes the picture like a little bit more difficult for them because they are a priori untrusted, like they just look like an address on the network. You don't have an off-chain signal of their credibility, like a DAO or a corporation or something. So that makes them fairly capital inefficient because we have to convince you of the fact that they are not going to be trivially compromised or participate in an attack. Another thing that's a little sad about home operators that today they are not really a large enough contingent to block super majority from capturing finality. So I believe we have about 5 to 6% of solo stakers on the network, and maybe 3.5% more participating in Rocket Pool and Lido committee staking module. So it's really far below the 33% that would be needed to prevent finality from happening if the other part was captured. And so if they are not so effective at that layer, like why are they still needed? In my opinion, for multiple things. The first reason why we really want to have home nodes on the network is because we assume that by being so numerous and by having so distinct preferences from trusted operators, they are going to be very good at providing censorship resistance. And the way that they do that today is essentially via local bidding. So if they are proposed the task of building a block, if they decide not to outsource it, they can decide to outsource it. But if they decide not to, they will impose their view of the network via this building. That's the first feature. Another feature that they have is you can think of them as an active layer of monitoring. They are paid to be around and to attest their view of the network. So that can come in handy. Let's say if the network was sufficiently under attack, like we know that we have this reserve army that's ready to step up. But you could make the case that other non-staking but still validating nodes, like full nodes, could also be part of that line of defense. Like they're also following the network, they're also executing the rules, and they would also detect if something went wrong. So the question is, can we get the best out of what the home nodes have to offer, and maybe make the picture better for them? Yeah. So today we are doing local building, like that's the contribution. I picture 3 roles: the role of attesting, like that's the envelope of voting; the role of including, that's the little truck; and the role of building with the crane. So yeah, local building is their way of including transactions. And if they outsource, now they're not really providing the role of including transactions, which is the dotted line, because now they're not sure that the builder will provide it for them. So when we unbundle, like we might lose some of these properties. So we have to be a little bit careful. The one way that we can recover the participation of home nodes in these essential services that they're really good at is to allow them to specialize in some of these roles. And in particular, I believe that decoupling the pressure that economic security imposes on home nodes would be a very good direction for making them just more powerful on the network. So when we try to fit every type of node, commercial or home node, through the same pipe, and this pipe is essentially bound to this idea of economic security, being fully slashable, having a ton of risk, we don't really put these home nodes like on the best footing. And for some of these services, we don't actually require like this extreme pressure to be efficient, to be trusted, to not get slashed at all. And so can we separate these two kinds of services, like the ones that don't require economic security from the ones who do? And so that's pretty much the pitch of rainbow staking, saying we can have on the one side a category of service which is fully slashable, like heavy services, and on the other side a category of services which is not slashable. And the services that are slashable could be fairly specialized, quite thin, have very sophisticated actors, capital efficient, that provide it. And on the other side, the non-slashable services could be much broader, much more fault tolerant than the heavy services. So that's the first separation, let's say vertical. And then I believe that since we are seeing delegations to be such a natural phenomenon in these services, we might as well also enshrine the fact that these delegations exist. And so we can have this horizontal separation where for each type of service, we can make the distinction between operators and delegators. To make a bit of a distinction between the two, so yeah, heavy services are slashable, light services are not. The purpose of stake in heavy services is really to provide economic security, so to make these commitments of saying money will be lost if something bad happens. For light services, the stake is a little different. Like we can call it stake, but it's more there to provide civil resistance and leader selection mechanism. So we want to be able to select the people who are good at providing the light service. For heavy services, because of that economic security, we expect them to be fairly intermediated, meaning like you will have agents that are sophisticated, that might have like longer chains of intermediation. Like for instance, Lido is a protocol, has node operators under it. Like it's very, like it's not just a single person with a box. Whereas for light services, we would want them to be like easy to provide and just like directly provided by operators as much as possible. Something about heavy services is, since they carry risk, it means that the yields or the cash flows that are earned by the operators are not fungible with one another. That's one reason why we have Lido, which is essentially a protocol that makes fungible the performance of different node operators. But for light services, since there's not real risk, because there's no slashing, we can have like much more fungible provision of yield or cash flows if we have them at this layer. And we can also have much higher fault tolerance because the risk may not be slashed and it can have like different penalties. For the heavy services, we need this very high alignment between the principal and the agent because, again, there's risk. Whereas for light services, it can be very low, and if the agent is not doing what you want them to do, you can very frictionlessly delegate away from them. And so, yeah, that's a picture I presented at Protocol Berg, but it's kind of my view of the ideal, let's say, state of the protocol, which is not one where we have a single, let's say, type of entity that does everything, but more like we have groups that do different things and that are keeping each other in check. And I think that's the best way to have resilience on the network, to ensure that these different groups, like the political economy that results from having separated between different providers who are specialized and very optimized for the role that they do, makes for a healthy network where we can just rely on the fact that we are not dependent on a single type of provider. It's in a way thinking of plurality at the scale of protocol design.
What is the screenshot down the left?
Oh, yeah. So I'll talk about this. So the includers are the ones who, I'll ramp up to this. So one key light service is Fossil. So Fossil is a censorship resistance gadget that selects every slot. In the current parameter, it's 16 includers who propose bundles of transactions that must be included into the block. So it's a service that you only need to pick 16 people, and they only need to give you like this list of transactions, and the network can enforce that they are included. So that's a very powerful service to augment the censorship resistance of the network. You select 16 nodes, but actually the honesty assumption is very weak. Like you only really need one node out of 16 that does a good job for censorship resistance, like to apply to the network. Once we have technologies such as zk-EVM, data reliability sampling, hopefully you can even provide that service with very weak hardware and very low capital, so much weaker than what you would need for staking and attesting. And so that means that we can actually have two different versions of Fossil. So one, which is the one that we're currently developing, where the roles are bundled, so where the validators are the ones who are also the includers, and one which we call light Fossil, which could even be hidden behind your wallet. So as long as you have some positive balance, you could sign up to be one of these includers. You could have the correct view of a chain through zk-EVM and DAS, like sampling is very efficient. You could have a stateless mempool at the back. You would still be pretty light. And you could just participate as an includer with this very weak assumption. And maybe sometimes you're offline, but it doesn't really matter. Like it's a very fault-tolerant service because you really only need like one of the person you sample at any given time to give you like the correct view and to provide censorship resistance essentially. And so I think that's a very powerful option for us to have censorship resistance provided almost like as a swarm at the network level. So if we are able to separate, let's say, the light services from the heavy services, there are some benefits to having like this firewall. So on the one hand, we can have better censorship resistance, let's say, provided by the light services. But on the other hand, that also means that we can have perhaps stronger assumptions on the providers that provide the heavy services. So we can still keep, in my opinion, the attesting layer fairly permissionless, but maybe we could even consider like having slightly higher minimum effective balance to participate at that layer, if you could also participate in the other layers more permissionlessly. That might be a good idea because, again, I think we really need to get to faster finality soon. The quickest way is to shrink the validator set, which doesn't mean kicking people out. Like again, today we have 1 million validators, but we really have 8,000 nodes behind them. So even matching this would be effective. But we could also be thinking of what this separation buys us in terms of assumptions on the heavy services. And I think that's an important question that we should ask ourselves. And another point on the economics of light services, so I'm saying let's send people away to these light services, but the question that would come is, well, are they paid? Are they incentivized? Like this is the part where it's a little bit more tricky. We have actually designs for incentivized Fossil, so it's possible. The question is whether it's desirable, because the minute you put incentives, the minute MEV jumps into the picture and can easily derail the mechanism's purpose, which is censorship resistance. There are questions like, for instance, let's say I invested recently in a better staking node because mine burnt out. So now I have this mid-sized node at home. Can I still use it for something useful? Like even if I don't want to attest, but I don't want to just do like a wallet thing. We are talking a lot about RPCs, partial state provision. Like that's a lot of designs that are currently being discussed. And so, yeah, another alternative is this idea of home provers with the protocols that distributed work. So in my opinion, in the future, like we won't lack options for services that fall under that category, and we may even have like alternatives to incentivize them, such that people are paid for the useful work that they provide to the network. And so, what should we do given this picture? I think shipping and seeing all of this tech that enables this future go live will really reshape our perspective in terms of what's possible with these different light services and heavy services. In particular, I believe after zkVM, full DAS, and fossil ship, like we'll have a very different perspective on what being a node means and what are the multiple possibilities of providing value to the network beyond just being like a single bundled staking node. Then we might have an easier time also articulating like the things we really want from our node. And so, yeah, I think we should accelerate on all of these tech tree and revisit the question every couple of months to see where we're at. Yep, thank you.
Any questions for Bante? You didn't?
Yeah, I don't know how super related it is, but if the staking limit goes down to 1 ETH, as has been said sometimes, obviously the APY for those that stake would go down. Do you think that would be enough of an incentive for someone to stake 1 ETH, as little as 1 ETH?
You mean if more people staked 1 ETH, the APY would go down?
It would, like, proportionally the gain of someone staking 1 ETH would be much less. So would people actually do it?
Yeah, so that's a point about capital efficiency. So I have fixed costs to staking, and these costs will go like way lower. And I believe in the meme of smartwatch staking that Justin has. Like you might be able to stake with like a Raspberry Pi or something very light. But it's true that the more capital you put on your fixed cost, the more capital efficient you are. And compared to staking pools that are able to put thousands of ETH on a single node or a single protocol or things like this, like you're always going to be at a bit of a disadvantage when it comes to like the real yield that you get from your node. So there was a lot of conversations like last year around issuance and how we should be thinking about the relative earnings of solo stakers versus home operators versus professional operators. I would say the question is still not settled, but I don't think we should do anything about it until we figure out more about this larger picture of future of staking. But yeah, I think it's a universal truth of capitalism that the more capital efficient you are, like the better you will fare in any system that ranks you according to that metric. Yeah. Yeah, thanks.
So, one question that's a bit random is if we unbundle all the roles into lots of specialized operators, how does this impact the ability to very simply have social consensus or organization to help fork the chain? Because today everything is so simple that there's only one thing to do, which is fork the chain. If there are 8 operators, how do you contact them? What do they need to do in order to?
Yes, I agree. So I think the worry that I have is the operators that are effectively in control of the chain are the attesters today. And as I was saying, like the home operators don't really have a blocking minority there. So there's a lot of like signals or things that they couldn't really do. Again, coming back to this picture, which is not at all an argument, but more like a mental model. I think once we get to that world, we may also have like much more tangible ways of triggering things such as a community reaction. So let's say, for instance, all these like millions of wallets that are passively doing fossil at the back, they might be emitting like messages to say, I've seen these transactions. These messages might have quorums of other wallets saying, we've also seen these messages. Over time, you can build actual evidence that can be used to programmatically trigger like certain actions. So today, we're kind of reliant on only having the attesters performing their role. If the attesting layer was fully compromised and was starting to censor, it wouldn't be like so easy, I think, to say, oh, something's off. Like we could do it, but there would be like a bit more of like community organization. So the idea with this is giving us the tool to make much more automatic and programmatic, like the reaction and the courses of action that we would want to take if, let's say, people were making inclusion lists but weren't included on-chain because they were still censored by the attesters. In the model that we would have with heavy fossil, it's the same people. Like the attesters are the ones who are also making the lists. And so now, when you have two groups and they're both doing like different things, you might be able to have like much more uncorrelated signals from either side, and then be able to programmatically trigger courses of action based on these signals. It's a rough picture. The Rainbow Staking post goes a little bit more into detail on this, but I think that's, will be the main value proposition to have better signals from entities that are uncorrelated from each other.
If we have permissionless signature aggregators, so where would they fit? They would fit in includers?
I'm not sure that we would need, for instance, economic security behind these aggregators.
For example, in Beam protocol, they
Right.
will come with proof, so you don't actually need any security from them because they will be provable.
Yeah, so there's actually two types of faults that you want to prevent against. First class is safety faults, and the second class is liveness faults. So you might still want to have some kind of economic penalty for liveness fault, like let's say if somebody is not doing their job. In the case of, let's say, light fossil, I don't actually think liveness faults should be penalized. Like I think if I was to point my Eve to Justin because I believe he will do a good job as a person making up inclusion lists, and I see that over time his performance has degraded, I can just like point my Eve away from him. For services that are maybe more critical, like aggregation, perhaps we would want to consider like economic penalties for liveness faults. Like if you are signing up to be an aggregator and you're not doing your job, maybe we do actually want to slash you, but it might be much lower risk than fully slashable, for instance. So it could be like just partially slashable. Yeah.
But if we have permissionless aggregation, then maybe I can delegate my E to, for example, Justin, and if his performance goes down, then I'll probably move my E to someone else.
Yeah, that could be a way to do it. Yeah.
Okay, thank you, Balaji.
Yep, thank you.